Okay, we're going to start with assigning oxidation numbers. And we have to start with oxidation numbers because the bulk of this chapter is going to be learning how to balance oxidation reduction or redox reactions. First thing, redox or oxidation reduction involves a transfer of electrons from one thing to another thing. So in order to be able to track where the electrons are going, that's why we have to be able to assign oxidation numbers and then figure out how oxidation numbers are changing. And then that will tell us what's going on in an equation. So let me share my screen because I've got the rules here. There we go. So there's a few rules to go through first. You'll use probably about half of them. Rule number one, if you have a pure element in a chemical reaction, the oxidation number is 0. For example, sodium metal, oxidation number is 0. Obviously, that will change if sodium metal becomes sodium chloride, then it will have a charge of plus 1. It is important, however, to be able to understand that oxidation number does not equal charge. Oxidation number doesn't have a physical meaning. It's just a representation of how well or how poorly elements attract electrons in a compound. Okay? Number two, in an ionic compound, elements are going to have an oxidation number equal to its charge as an ion. So in that example, sodium chloride, sodium will be +1 and chloride will be -1, both in charge and oxidation number. Number three, if you have a binary compound, especially molecular compound, which is made of only nonmetals, the element that has a higher electronegativity, meaning it's closer to fluorine, because remember, fluorine has the highest En of all the elements. The element closer to fluorine has a higher electronegativity, and that one, you're going to assign an oxidation number the same as the charge of the ion. So if you have nitrogen monoxide, nitrogen and oxygen is closer to fluorine, has a higher En, therefore the oxidation number of oxygen is -2, just like the ion. Number four, same kind of thing, because fluorine has the highest electronegativity, its oxidation number is always -1, the same as its charge as an ion. Number five, oxygen is like 99% of the time -2, unless it's in a compound with fluorine. Then of course, fluorine has a charge, sorry, I keep saying charge, it's not right. If oxygen's in a compound with fluorine, fluorine takes an oxidation number of -1, and then oxygen will be something else, which I'll talk about in a second. Hydrogen is always +1 unless it's with a metal. Again, you probably won't see this, but if it is with a metal, then hydrogen becomes -1. Number 7, the active metals, which are groups 1 and 2 and aluminum. Group 1 is going to have an oxidation state of +1, group 2 +2, and aluminum +3. So they stay the same as their charge. 8 and 9 are related. And this is going to play a big part when you go to assign oxidation numbers for compounds that have 3 or more elements in them, because you're going to do a little bit of arithmetic. So for compounds, their overall electrical charge is 0. They're neutral. So the sum of all of the oxidation numbers in a compound has to equal 0. And number 9, for a polyatomic ion, the oxidation states of all, as I say oxidation state, it's the same as oxidation number. It's 2 different words for the same thing. For a polyatomic ion, the sum of all of the oxidation numbers has to equal the charge of the ion. Now I'm going to go and share my iPad so I can show you some examples. Make sure I can see what I'm doing. So there we go. These are the 2 examples that were used in the list of rules. So we'll start with a neutral compound, calcium carbonate, and then we'll go to the polyatomic ion. My iPad here. All right, so I will show you the way that I do this. I am going to put individual oxidation numbers at the top. When I write the numbers at the top, that means it's the oxidation number for each individual atom, which is what the questions are going to ask you for. If I ask you to identify the oxidation number for all of the elements in calcium carbonate, I'm asking for it per atom. On the bottom, I'm going to put the totals, and you'll see why in a second. So when you have compounds like this or ions like this that have 3 or might even possibly have more than 3 elements, I want you to start at the edges, because the elements that are on the edges are probably going to fall under one of those rules. So in the first example, oxygen is one of the rules and calcium is one of the rules. Oxygen because it's not in a compound with fluorine and it's not a peroxide. So it's going to have the same oxidation number as an ion, as an oxide ion, and that's going to be -2. So each oxygen atom in this compound has an oxidation number of -2. Now, there is a subscript here. So there are 3 oxygen atoms in this compound, each one having an oxidation number of -2. So it's -2 times 3. The total is -6. Okay? That's as much math as you're going to have to do here. Well, no, I lie. It's a little bit more in a second. Now I'm going to skip carbon because I told you to start on the outside. Carbon doesn't have a rule for it, but calcium does. Calcium is a group 2 metal. Therefore, its oxidation number is the same as a calcium ion, which is +2. There is no subscript on calcium, so it's +2 times 1 calcium atom, which means there's a total for calcium of +2. Now, rule number 8, the sum of all of the oxidation numbers in a neutral compound has to equal 0. So what number +2 minus 6 is equal to 0? That number is +4, right? +2 + 4 minus 6 equals 0. Now, that +4 is the total, right? Total oxidation number over however many carbon atoms are in the compound. In this example, there's only 1. So, why? Sorry, I don't know if that was loud or not. So the total oxidation number for carbon is +4. So this right here, that would be your answer. Calcium +2, carbon +4, oxygen -2. Now, going down to the ion, same thing. We have 3 elements, but we're going to start at the edges because there's a rule for hydrogen, there's a rule for oxygen, there is no rule for phosphorus. So oxygen is -2. This time there are 4 oxygen atoms, so the total is -8. We're going to go back to hydrogen. It's not in a compound with metal, so it has a oxidation number of +1. There are 2 of them, so the total is +2. Now, because it's an ion, we have a charge, which means the sum of all of the oxidation numbers has to equal the charge. So what number +2 minus 8 is equal to -1? And that is +5. Okay? And again, this is the total at the bottom. So the +5 is over all of the phosphorus atoms, which in this case is also 1. So the oxidation state for phosphorus is +5. Now the reason why they don't have any physical meaning is I can take a different ion, which has the same 3 elements in it. Let's go with, instead of dihydrogen phosphate, we'll go with hydrogen phosphate, which has a charge of -2. Move my arrow. Yeah. Okay, so same thing. We're going to go, oxygen is -2 times 4 is -8. Hydrogen is +1. There's only one hydrogen there's only one hydrogen atom now, so that's +1. And this time it has to equal -2. So what number +1 minus 8 is equal to -2? Oh my God, my brain doesn't work. 5, 6, that'd still be +5. Right? Yeah, interesting, it didn't change. Sometimes it does. All right. Well, in that case, let me show you. I should just open a new note. But anyway, let me show an example of what I was trying to do before I did a complete self-own. I end up having the same oxidation number for phosphorus. Okay, we'll try SO2, SO3, and just SO2 and SO3. And go back. Red, hello. Oh, because it's an eraser. Oh, this is what happens when you don't do anything for 2 months. Okay, I'm sure you can understand how I feel. All right, we'll start with SO2 first. Oxygen -2 times 2 is -4. That means this is +4. So sulfur in sulfur dioxide is +4. However, if we go over to SO3, sulfur trioxide, -2 times 3 is -6. This has to be +6, which means sulfur is now 6. That is what I was talking about when I meant it doesn't have a physical meaning. So the oxidation number for the same element can change depending on what compound it's in, because sulfur is going to attract electrons differently when it's surrounded by 2 versus when it's surrounded by 3 atoms. Okay, I want to try one more example before I let you do some practice. Let me do again with the eraser. Okay, calcium phosphide. Okay, Ca3P2, calcium phosphide. Now, in this example, again, we're going to start with the element that has a rule attached to it. So phosphorus doesn't have any rules, but there is a rule for the active metals of groups 1 and 2. So calcium is +2. There are 3 of them, so that's +6. Phosphorus total has to be -6. So here's the difference. There are 2 phosphorus atoms. The total oxidation number for both phosphorus atoms is -6. So when you go upwards like this, you have to divide. So -6 divided by 2 is -3. Okay, so be careful of that. I think that's it for today. Now let me look all weird and try to figure out how to stop recording. Bye!